Welcome back to IoT series. In this video, we'll be discussing the data protocols. So as a part of the IoT communication technologies, here we'll be speaking about the third component, that is data protocols. So we'll understand the 7 protocols which are mentioned here one by one. We'll look into it in detail. So let's start by understanding the definition of data protocols. Protocols are the rules and regulations, and data protocols means all the rules and regulations which are directly connected to data. That is how the data would be accessed, how the data would be stored, and how the data would be distributed throughout the IoT networks is what we can define as data protocols. So here the communication or the data transfer could be between a sender or receiver, that is client and server, or it could be between a broker, here publisher, here subscriber, and here broker could be there, or vice versa. We'll look into what broker, subscribers, client servers, how does it work in the upcoming protocols. So first one which we'll encounter is MQTT. MQTT is very important from exam perspective. So, and it is a very simple topic again. So MQTT is a lightweight publish subscribe protocol. So whenever we speak of MQTT, the first thing which has to blink is publish, subscribe, and here middle there would be a broker. It is PBS. PBS protocol optimized for constrained devices and constrained networks. So in previous videos, we have discussed what constrained devices are, what constrained networks are. So here, this protocol is ideal for environments having high latency, low bandwidth, and unreliable networks. Speaking of the remote IoT applications, all these factors are present there. So in such conditions, we can make use of MQTT protocol. So here MQTT protocol will decouple the publishers and subscribers for scalable communication. That is segregating it out. It will help us to efficiently establish the communication. So the messages are organized into structured topics. So looking at the figure here, I'll just explain it. So yeah, if you can see here, all the publishers are here, all the different devices are publishing the data, and here the data would be stored in different topics at the broker's place. So that's what we have discussed there. Different topics for efficient data management. So hierarchical grouping happens here in case of MQTT. So there are three QoS levels, that is quality of service. Three levels are there. The first one is at most once. At most once means best effort delivery. That is either message could be lost or duplicated in this case. Speaking of at least once means there is guaranteed delivery, but then duplication is possible here. Then we have exactly once. Exactly once means delivery is confirmed, guaranteed, without any case of duplication. Then we have MQTT provides flexibility and operates independently of the underlying applications. So this again speaks of the application independence. Then it allows publishers to define default messages in case of unexpected disconnections. That is what we've spoken about the remote applications, right? In that case where the network is not stable enough, in such conditions, the default messages could be prepared and they could be sent or defined in case of unexpected disconnections. So the message ranges from 2 bytes to 256 MB, thereby minimizing the network overload. Speaking about the MQTT components, there are three components here. First one is broker. Broker will act like a central server. So it will manage the communication between the publisher and the subscriber. So here we have the broker, which will manage the communication. Publisher is the devices which will send the message to broker under specific topics, and subscriber is which will receive the message from broker for subscribed topics. Here it is specific topics they'll publish, and on the other hand, it has whichever topic I have subscribed, I'll get the message for those particular topics. Then speaking about the operational principle, so it is built upon the hierarchical topics. That's what we have discussed, and then it makes use of TCP connection here, TCP for communication here. So publishers will send messages that are tagged with a topic to the broker. Broker will distribute the topic contents to all relevant subscribers. So this protocol reduces the network traffic by sending the messages to only those devices which have subscribed. So if I have not subscribed to a particular topic, I won't get those messages only. So multi-broker communication means brokers can share topics to connect subscribers across multiple networks. So all these they speak about the different features of MQTT. Moving on further, we have the message types here. So there are nearly 14 message types which are supported in MQTT. So the first one is connect, that is client's request to connect to broker. Then CONNACT, that is acknowledgement which is sent back by the client, okay, by the broker after connection is established. Then we have publishers message sent to the broker, or it could be vice versa. Pub act is pub acknowledgement, that is acknowledgement of published message. And we have pub rec, pub rel, and pub comp. So these are messages for assured delivery across various stages of communication. Then we have subscribe. Sub ACK, subscribe means subscribers request to get a message, and sub ACK means after getting the message you are sending the acknowledgement. Unsubscribe means to not get the message, so you're unsubscribing to not receive a message from a particular topic. And unsub ACK is the acknowledgement of unsubscription access. Then ping REQ and ping RESP, that is response and request. So those are heartbeat messages for communication health. Then we have disconnect, that is the notification of client disconnection. So all these are different message types which are used. Looking at the figure here, this figure speaks about the operation and its stakeholders. So looking at the publisher, we spoke about publisher. Those are the devices which will send the data to broker under specific topics. Devices here could be refrigerator, thermometer, microwave, any IoT devices. Okay. Then you have broker here. Broker acts as a central server which will segregate. And coming to the subscriber part, subscriber will receive the updates from the broker for the topic whichever they are subscribed to. And in case of the devices which are present here, these are all actuators. So if refrigerator or temperature has increased to, if let's say if the thermometer temperature has increased to a great extent, then it could send to the application here, so where which will in turn turn on the fan, something like that. Okay, this is just a vague example. So this is what the MQTT basically speaks of. So from efficiency perspective and flexibility perspective, MQTT is best, and it is widely used in smart homes, as we can see here, industrial applications, health monitoring networks, and so on. So this was about MQTT. Next protocol which we'll encounter is Mqtt-sn. So it is MQTT for sensor networks. So Mqtt-sn is an extension of MQTT protocol, which is designed specifically for wireless sensor networks and constrained devices. So here this is particularly designed for WSN, wireless sensor networks. So the focus is on minimizing the bandwidth usage, operating under high link failure conditions, and supporting low power and low cost nodes. That's what we have spoken about, the constrained nodes and constrained network situation, right? So here it is elaboration of whatever we have spoken. So looking at the key features, we'll understand. First one is connect messages. So connect messages split into three messages. So out of which two of which are optional, that is to communicate will topic and will message. Next, we have topic identifiers. So the topic names are replaced with 2 byte topic identifier in publish messages. So this will reduce the bandwidth usage. Then topics need to be registered with broker, generating a topic identifier. So here we speak about the topic registration mechanism, where the identifier is shared with publisher and subscriber after being registered. So publisher, subscriber, only when a topic is registered, it could be further subscribed here and published here. It works on pub-sub model. We know that. So it supports predefined topic identifiers. There are predefined topics or identifiers which will eliminate the need for topic registration when identifiers are pre-known, when they are usually used or been existent. In that condition, we can make use of these predefined topic identifiers. Then we have, it allows publishers, subscribers to discover brokers network address in absence of pre-configuration. Discovery process also happens here. So speaking about the persistent subscriptions and will messages, there is persistent subscription and will messages. That is, will topics and will messages are persistent during a complete session. Will messages can be modified during the session. Speaking about the devices, so here it will also support the sleeping publishers or subscribers using a keep alive offline mechanism. So we have keep alive offline mechanism. Looking at this figure, the MQTT-sn types. So MQTT-sn acts as bridge between the MQTT-sn devices and MQTT broker. So we know it acts as a central device. So there are two types of gateways here. So the first one is transparent gateway. So here we have the transparent gateway. Transparent gateway will enable individual connection for each MQTT SN device. So there will be individual connection for each device. So each device is treated as separate client by the broker. So they'll have individual identity. Okay. So there is direct communication happening here, and it is simpler and easy to troubleshoot. So in this case, it has high overload and it is less scalable, because establishing individual connections for each and every device becomes tedious, right? So quite contrast to that, we have aggregating gateway. So aggregating gateway will combine the traffic from all devices into a single connection to MQTT broker. So that's what we can see here. It is just one, so many to one condition here. So it acts as a central point here, and it is efficient for large scale and easy to deploy. But there are higher processing demands, potential for bottleneck condition can happen here. So this was about the Mqtt-sn types. We have covered all the important points related to MQTT. So next, moving on further, we have CoAP. So CoAP stands for Constrained Application Protocol. So Constrained Application Protocol is a lightweight protocol designed for communication in constrained environments. So CoAP ensures efficient communication over low power and lossy networks even when devices have limited resources. Again, speaking about the constrained networks and constrained devices. So CoAP will make use of a compact 4-byte binary header, significantly reducing the overhead. So this again speaks about the lightweight design only. So it is optimized for constrained devices and networks such as those with low bandwidth and high error rates. That's what constrained devices and constrained networks they have highlighted here. So speaking about the communication model here, it will make use of request response model, which is very similar to the HTTP connection. So here communication is asynchronous and it will rely upon the UDP, that is user datagram protocol, for transferring the message from one to another. So it also supports both unicast and multicast communication. Next, we have the CoAP supports easy integration with HTTP by maintaining a stateless architecture. That is, stateless integration with HTTP is being spoken here. So messages will be carried. Messages carry the info about the source, eliminating the need for server to store the connection states. Next, we have about the CoAP and its built-in proxy mechanisms. It supports caching, which reduces the impact of lossy networks. So caching uses a maximum age field for the identification of message validity. So speaking from the security perspective, CoAP will support the DTLS binding. DTLS is datagram transport layer security binding to provide encryption and authentication. Next, we'll look into the message types. So there are 4 message types here. First one is confirmable, CON. So here it speaks about the reliable messages which require acknowledgement. Next, we have retransmitted using exponential back off until the sender receives an acknowledgement. So it works upon the acknowledgement factor. Okay. Next, it makes use of reset message. So if the receiver is not able to process the message, then a reset message is sent back instead of acknowledgement. That's what confirmable. Definitely message is sent or acknowledgement is sent. Coming to non-confirmable, non-confirmable is for the unreliable messages which do not require acknowledgement. It could be in case of sensor readings. So it is used for low priority and time sensitive data. Speaking about the acknowledgement, it is sent by the receiver to confirm that whatever message you have sent is successfully received. It is successful receipt of CON message. Successful receipt of this message is acknowledgement. And reset is sent when the data is not transferred properly or the data is not processed properly at the receiver's end. That is reset. So here we have the figure which speaks about the position of CoAP protocol in the OSI stack. So firstly, we have the application layer here. In application layer, the communication between the IoT devices and the backend happens here. So it will make use of the request response model or communication model to establish the communication. Speaking about the transport layer, so in transport layer, CoAP is available. Okay, so CoAP will rely on the UDP, user datagram protocol, for its transport layer. So UDP is selected because it has like low overhead and suitability for lossy networks. Then speaking about the network layer, in network layer we have IP. So it makes use of internet protocol for addressing and routing purpose. So IPv6 or IPv4 can be used here depending on the environment. In physical layer we have the constrained PHY. That is, any constrained physical layer protocols could be there. Low power communication protocols could be there like Zigbee, BLE, Bluetooth Low Energy, and all of that. So they are used for low energy, low power, low bandwidth, high lossy networks which are available in the IoT applications. So this was about the figure. Looking at the features here, we have discussed all these features. So it is a suitable web protocol for integrating IoT and machine-to-machine services in constrained environments. It makes use of UDP. Yes, we have spoken. Message exchange between endpoints and networks between nodes is asynchronous. Asynchronous, yes, we have spoken. Limited packet header is there to reduce the overload. Then it has provisions for URI, and content type identifier is used here. So it additionally provides DTLS, datagram transport layer security binding from security perspective, and it has a straightforward proxy mechanism and caching capabilities responsible for overcoming the effects of lossy networks without putting extra efforts. So again, this also we have spoken. This protocol uses the stateless mapping with HTTP. Again, as we have discussed, we know this CoAP request response model. So if you look at this diagram, there are three models here. So three models are used for handling the responses. So the first model speaks about the confirmable and non-confirmable messages. So confirmable messages are those messages which will give an acknowledgement. So they are like reliable messaging. So they'll need acknowledgement. So if acknowledgement is not received, then the message is sent again. That it is retransmitted. And example could be like if you are sending some commands. So if the command is received here, there would be acknowledgement sent back. If not, then you'll expect again to retransmit after a certain time. Speaking about the non confirmable messages, so here no acknowledgement is required. Example could be any sensor data which is sent. It could the data is not that crucial, not that important. In such conditions, we can make use of this model. Next, we have piggyback responses. Piggyback responses will include the servers where the response data is within the acknowledgement message itself. So acknowledgement plus data is sent back. So this approach will reduce the number of messages which are sent or message exchange. Example could be a temperature sensor which will send a request and the server will immediately respond with the temperature value along with the acknowledgement. That is, I've got the message and take this is your temperature. Both are given here, acknowledgement and data. Next, we have separate responses. So here it is used when the server cannot like immediately respond to any request. In that condition, the server will send empty acknowledgement to stop retransmission firstly, and after that server will send the response to the actual CON message. Okay, so it will reply back to that particular message back. So this was about the request response model. So in exam, if they ask, this diagram is expected and you have to explain this. So I have written down all the points here. Then speaking about the multicast support, so CoAP will support multicast requests over UDP, and it will enable efficient communication with multiple devices simultaneously. So request responses to multicast requests depend upon the application and may not be always required. So CoAP will make use of the HTTP methods, which are like HTTP methods, the popular ones which we know. Get is to retrieve any particular resource, or put is to upload or update or create a particular resource. Post is to submit a data to a resource, and delete is to remove a resource. So this was about the CoAP. Along with that, we also have a few more points, that is token based message matching and reliability options. So token based message matching means tokens are used to match the requests here. So as we are speaking about the asynchronous communication, tokens would be used to match the requests with the responses. Speaking about the reliability options, reliable message delivery is optional here. That is enabling devices to balance the efficiency and data integrity on both the sides. So this was about the CoAP protocol. Next, moving on further, we have Amqp, that is Advanced Message Query Protocol. So Advanced Message Query Protocol is a middleware messaging protocol that will facilitate robust and secure communication between publishers and subscribers in distributed systems. So it is designed to provide reliability, flexibility between different systems and different platforms. So speaking about the features here, so it supports message oriented communication. So the communication happens based on the messages. So the delivery guarantees include at most once, at least once, and exactly once. The three QoS levels which we have discussed previously in MQTT, the same thing also follows here. Okay, so a credit based flow control mechanism prevents the message from overloading and ensures efficient resource utilization. Now, this again speaks about the flow control and efficient resource utilization. Speaking from the security perspective, it supports authentication, and there is optional encryption which could be applied using SSL or TLS. Speaking from the interoperability perspective, there is wire level protocol standard which ensures any system to interpret AMQP byte stream can communicate. That is program language or platform independent perspective, irrespective of the program language and the platform it can communicate. So this was about the features. Here we have the figure 8.19, which speaks about the components and their relationships. So first we have is publishers. So we know publishers are those devices or entities which will send the messages to the broker. We spoke about MQTT broker. Here it is AMQP broker. So here publishers will not directly send the data. So they have to send the data through the broker only. So here there could be queues to manage the data also. So speaking about the AMQP broker, broker will be the central component. So he will get the message. So after getting the message queuing is happening. Let us temporarily store the message for to be sent to the publisher here. Next, we have routing. Routing is distributing the messages to proper subscribers. If they are subscribed to that particular topic, they'll get the message. Then we have maintaining the reliability. That is, it will ensure, the broker has to ensure that guaranteed message delivery should happen depending upon the configured deliver mode, that is at most once, at least once, or exactly once. Then we have subscribers here. Subscribers will consume the message from broker. They can receive the message based on subscription to specific topics. So yeah, about the figure, all these components are well known to us. Moving further, yeah, we have queues, which are logical structures maintained by the broker. So they'll temporarily store the message until delivered to the subscribers. So they will help us to decouple the publishers and subscribers separately, thereby storing the memory. Then we have operational principle here. Operational principle means like what are, how does it execute and all. So AMQP operations are structured into different sessions, links, and frames. Firstly, we'll speak about frames which are present in AMQP. There are many connections and message transfers which happen between the frames. So frames are used to manage the connections, sessions, links, and message transfers. There are 9 types of frames. First one is open. Open means it will help us to establish a communication between two nodes. Then we have begin. Begin is to initiate a session. Initiate a session to send message. Then we have attach. Attach is to establish a link. Then we have transfer. Transfer is to transfer a message over a link. Then we have flow. Flow is to update the flow control. So from here it has to go here, then here. It cannot go directly like this. So something like that. To update the flow control state, to manage how the message will flow from the sender to the receiver, we make use of flow. Then we have disposition. Disposition is to update the transfer state, that is like confirming message receipt or settlement kind of things. Then we have detach. Detach is to terminate any link between two nodes or n number of nodes. Then we have end. End is to close any session, and along with that we have close also. So close is again used to terminate any connection, the entire connection you are terminating between two or many devices. Next we have message transfer and flow control. That is, whenever a link is established using attach frame, message is sent via transfer frame. So here flow control will ensure that sender does not overwhelm the receiver with excessive messages. Only when the transfer frame works properly or the attach frame works properly, acknowledgement is received, then only further response could be generated. Here, in order to avoid the overwhelming or excessive message sending, we make use of proper flow control here. So changes in message states are communicated via disposition frames, that is to update any changes which are present. Then we have sessions here. Sessions will allow like bi-directional. It could be logical connection between two peers. So here we have multiple links, that is unidirectional. It can exist within a single session. So this will enable flexible communication. So here each session will have a begin frame and there will be a end frame. So speaking about the advantages here, first one is decoupling. That is, publishers and subscribers are decoupled, separated. So this will enhance the scalability. Then we have flexibility. That is, it supports multiple messaging patterns. So there are many message types, 9 types which we have seen here, 9 frames which we have seen here. So it will enable request, response, and publish, subscribe, all those things are included here, right? Next we have interoperability. So standardized at the wire level. So this will enable diverse systems to interact efficiently. Then we have efficiency. Again, flow control, session management, all those things are there that will increase the efficiency. About the AMQP protocol. Moving on further, we have Xmpp protocol. Xmpp stands for Extensible Message and Presence Protocol. So this protocol is important one from exam perspective. So Xmpp is a open source XML based protocol. So it is designed for usage in the real time, and it has message oriented middleware. So it will facilitate exchange of structured data, that is messages and presence info between the network nodes. So we'll look into the features one by one. So the first feature speaks about the open source again, yeah, as we have seen. Then XMPP supports diverse applications, including, so here they've spoken about the applications. First one is instant messaging and presence signaling. Then we have voice and video communication, which happens via VoIP. Then we have file transfers, and then there could be applications about the IoT applications like smart grids, publish subscribe systems, which work upon the that principle. Then speaking about the client server architecture, so communication between the peer is happening through XMPP server. So this will enable efficient and proper message delivery. Then speaking about the anyone can host XMPP server, enabling self-contained communication ecosystem. So here it is like decentralized model. There is no authority to control anything. Next we have the operational principle. So here each user in a network will get a unique JID. JID is Jabber ID. So this is similar to the email. So the email which we have, it is similar, quite similar to that. So here we have user. So user is the username, followed by that we'll have the domain name. Domain name will refer to the server hosting the XMPP service. Then we have the resource or the device here, which will differentiate different clients for the same user. So here if it's mobile, it could be for one resource. Here if it's laptop, it could be for another resource and all. So here resources are assigned numerical priority. So depending upon the number priority, they are sent accordingly. So whichever GID has the highest priority would be routed first. Then XMPP functions are XMPP functions as an overlay network will enable communication across different underlying network types. So again, it helps. It speaks about the flexibility and scalability aspect. Next, looking at the XMPP technologies. So first one we have is core. Core technologies of XMPP will manage the XML streaming and basic operations. We look into what basic operations are. First one we have is XML base layer. So this is used for structured data exchange. Then we have TLS encryption for secure communication. Then we have presence information, that is to track if there is any user available in the network. Then we have jingles. So jingles will handle the session initiation for multimedia applications. It could be voice, video, file transfer and all. So media transfer happens directly via media or media relay. So it could be between the clients, that is peer to peer, or via the media relay. Then multi-user chatting. So by making use of this protocol, it will enable group conversations in chat rooms or channels. So this will offer robust control features, like there could be a moderator and user banning and all that stuff. These are the features which are present for multi-user chatting. Then we have pub-sub event-driven communication. That is event-driven communication. User can create a topic, subscriber will receive the updates. So this could be used for useful for alerts, notifications, and syndication of the services. Then we have BOSH, that is bidirectional stream over synchronous HTTP. So this will optimize the traffic between the clients and servers by eliminating the frequency pooling. So it will also reduce the latency here, and the network bandwidth usage is also reduced here. So if you look at this figure, this speaks about the components. So the first component which we have here is the client. So it could be client 1A, 1B, 1C. So this clients will be connected to the server and they will send the message or get the message back. So multiple devices for a single user can connect simultaneously, and these are identified by the values. The different names are given, right? Client 1A, like that. Then we have XMPP servers here. So this server will act like central communication hub. This will manage the message routing, and it will also detect the information presence. So this will ensure that clients can communicate indirectly. So they are not communicating directly here. Indirect communication is happening through the server. Then we have plugins here. So plugins will extend the server functionality from custom requirements like multimedia communication or message archiving and all of that. Then speaking about the components, so components are any external software modules which will interact with the XMPP server, and they'll provide additional capabilities like a group chat feature or pub-sub features which we have discussed above. Now let's look into the advantages. First one is real-time communication. So yeah, it enables real-time communication. That's when you can do the group calling and all. No? Then we have flexibility. That is multiple devices can be connected to it. Multiple messages could be sent to the server. Yeah. Then speaking about the scalability. So because we have a decentralized architecture, it is easy to scale, easy to increase the servers and all. Then speaking about the extensibility, so XML based design will make it very simple to introduce new features without breaking the existing ones. Speaking about the security perspective, it has strong encryption and authentication mechanisms which will ensure that data confidentiality and integrity is maintained. Next, moving on further, we have SOAP protocol, that is Simple Object Access Protocol. So SOAP is a lightweight XML based messaging protocol which is designed for exchanging the structured info in the web services. So this will enable interoperability between systems with different platforms or operating systems and ensure reliable communication over variety of network protocols like HTTP or SMTP. So firstly, this is a platform and language independent, so it does not rely on any particular platform or language. So by making use of XML, this is achieved. Then we have it forms messaging layer in web services protocol stack. So it works upon the web services messaging, so that particular standard it obeys. Then SOAP can operate over different application layer protocols, that is, it speaks about the transport protocol neutrality. Again, we have it supports additional features like web service addressing. It has firewall compatibility, speaking from the security perspective. Next, looking at the components. So first component which we have is envelope. So envelope will define the overall structure of SOAP message. So here we can include the processing instructions, start and end of message, all that could be stuffed in the envelope. Then we have encoding rules. Rules will tell us how the data types are represented in the message. It will also tell us how the different formats could be handled for different applications which are used. Then we have convention. Convention will define the web procedure calls, and it will also tell us the structure of the responses which we get. Layer we have is SOAP, that is web services messaging. So SOAP is depicted as central messaging protocol which will enable the structured communication between the web services. So it will define the format, and it will also tell us how the messages are processed. Then we have in the TCP layer we have HTTP and SMTP. So HTTP post is for the web based communication, and the SMTP is for the email based communication to deliver the messages to the end points. Next, speaking about the target destination, we have endpoint URI. So this will refer to the like where it has to reach, what is the URL or what is the server address, the where the SOAP message has to be sent. Then we have application. So application layer integration happens by using the SOAP messages. So this will enable the integration happens very smoothly, and the structured format will ensure easy passing and integration with the logic. Speaking of the advantages and disadvantages now, first one is we have interoperability. That is, we have spoken about the XML based structure which will help us to uh, access it and use it across different platforms, across different programming languages. Then we have reliability, that is, we make use of well defined standards to ensure accurate and reliable communication. Extensibility is additional functionalities can be added, and firewall and proxy, yes, security and safety perspective is always there. Speaking about the limitations, first one we have is performance overload. That is, XML based structure will increase the message size and passing time, which will thereby reduce the performance down. Then we have verbosity. The SOAP messages are more verbose, so this will lead to increase in the bandwidth usage. Then speaking about the complexity, so SOAP will require multiple specifications, making it very complex compared to other protocols like REST. So this was about the SOAP protocol. Moving on further, here we have the working of SOAP. So a SOAP client will send structured request firstly to the server. Server will process it and returns the structured response, which can directly be passed and integrated to client's application. So SOAP messages are transferred over application layer protocols. Here we make use of HTTP and SMTP protocols, and along with that there is firewall present here, and proxies are also present here from to make sure that there is a reliable and safe communication happening. The next protocol which we come across is REST, representational state transfer. So REST is a software architectural style that defines a set of constraints for creating web services. So this basically speaks of a framework or an architectural style which is used to design the web services. So RESTful services are stateless, and it will enable interoperability between multiple devices. So stateless means RESTful systems will not store the client states in the server. So here each client will request a self-contained leading a self each client request is self-contained. So this will lead to faster, reliable, and scalable services. Then REST uses HTTP for network transfer. We have get, post, put, delete. Get is to read a resource, post is to create a resource, delete is to remove, and put is to update. Then we have REST sends data in various formats. So again, speaking about the data formats, we have HTML, XML, JSON, and all. Then looking at this figure, this will speak about the representation of REST style and what are the components associated with it. So first is resource URI. So a resource is identified by a unique URI. URI is unique resource identifier. So next we'll look into the figure, a representation of REST style and its components. Next we'll look into the figure, which is a representation of the REST style and what are the components associated with it. So the first one is application. So in application layer, there is interaction between the application and the client. So REST will make sure that there is uniform interface and proper communication or like delivery of messages happening here. Then we have resource URI. Resource URI is like uniquely identifying the resource, unique resource identifier. This will act like an address for accessing a specific data or a specific functionality. Then here we have the HTTP models. So get, post, put, delete. We have discussed this. Then we have different formats here. So REST responses could be POX, that is plain old XML. So this is a XML data format. Then we have RSS. RSS is used for the syndication feeds. Then we have JSON. JSON is lightweight and commonly used for its for no, general applications. Yeah. So this was about the figure here. Next, let's look at the advantages. So first advantages, we have enhanced network efficiency because we are making use of so many formats and we are making use of different HTTP methods. It supports enhanced network efficiency. Along with that, there is uniform and simple interface, scalability and reliability, of course, because it is a framework or an architectural style which is used to inculcate or design the web services. Then it has dynamic discovery and like for supporting the web resources. It is easy to modify and it is portable across different platforms. So this was about the advantages. Next we'll look into the 6 constraints of REST. So the first one is statelessness. So here each request will contain all necessary info, but servers do not maintain the client state. That's why it's called as stateless, right? Then uniform interface. Uniform interface means it will provide a simplified architecture and it decouples the system components. Then you have cacheability. These are the responses which will include the cache information to improve the performance and reduce the service load. Then you have client server architecture, which speaks about the separation of user interface along with the data storage, which will enhance the portability and scalability aspect. We have layered architecture here. So here layered architecture, in the sense clients are not aware of about the different server types, thereby allowing intermediate layers for load balancing and security perspective. Then we have code on demand. That is, this is an optional feature to extend the client functionality temporarily by downloading executable code from the server. So next protocol which we have is WebSockets. Next protocol which we have is WebSockets. So WebSockets are a standard full duplex communication protocol that operates over a single TCP connection. That is, it will speak about the real-time bidirectional data exchange which will happen between the client and server. So WebSocket is a OSI layer 7 protocol. OSI layer 7 means that will come under the application layer on topmost, and it relies on the TCP protocol, that is for layer 4 protocol for reliable byte stream transport. Then it works over HTTP port 80 and it has 433 which is encrypted via WSS. So this speaks about the compatibility with HTTP protocol. So the initial connection uses the HTTP handshake, which will ensure that there is compatibility happening between with the HTTP based network. It will also comprise of the proxies, firewalls, and all of that. Looking at the advantages, full duplex communication, which is quite not like the HTTP one. Then it has the reduced overloads compared to the older methods. Then it supports the real-time data transfer between the clients and servers. Speaking about the URI schemes, we have WS for unencrypted connection and WSS for encrypted connection via TLS or SSL. So next, it makes use of minimal framing. So small headers are present here and payloads are present here for optimizing the communication. So here frames will allow for multiplexing the multiple streams, thereby avoiding larger payloads and other complex situations. Looking at the operational principle here, so firstly client will send a WebSocket handshake via HTTP. Next, server will respond to the HTTP response, HTTP, and provide a HTTP response. Once the client and server link is established, connection operates independently. So independently of the HTTP protocol. So here messages can be split into multiple frames for efficient data transfer and multiplexing feature. Next, looking at this figure, so here this is like a OSI layer representation. So here WebSocket is shown as a protocol at the application layer. So and under application layer only we have WebSockets. And speaking about the TCP, so transport layer we have TCP for communication purpose. So this figure, like, it will speak about what is the role of WebSockets and what is the role of TCP in the OSI model. So this was about the WebSocket. Here we have tried covering all the important protocols. If you have any doubts, do let me know in the comments. And stay tuned. In the upcoming videos, we'll be discussing the identification protocols and other stuff. So make sure you don't miss out any of the content. If you have any doubts, do let me know in the comments. And thank you.